Okay, the next section will be about probabilistic methods. So what is probabilistic method? The basic idea that the probabilistic method 2 is just give a matrix, the rating matrix, user item rating matrix, and we want to determine the probability. So we want to know the probability that the user Alice will like an item I. And base the recommendation on such this probability. So if the probability is high, then okay, we can make sure that Alice will like that item. But if the probability is low, then we are not sure whether Alice will like that item. So the calculation of this rating probabilities will be based on the bias theorem. We want to know how probable is rating value 1 for item 5 given Alice's previous rating. So it means this is based on the conditional probability. The probability of item 5 equals to 1 given X. So X means the Alice previous rating. So if Alice give 1 on item 1, then what is the probability that the item 5 equals to 1? If item 2, the rating is 3, then I want to know what is the probability that item 5 equals to 1, and so on. So this is the bias theorem. You want to know the probability of Y given X. Then the probability of X given Y multiplied by the probability of Y divided by the probability of X. Or we can do the multiplication. We can do the multiplication for all the probability for X given Y multiplied by the probability of Y. So the assumption is ratings are independent. So independent means, yeah, we don't have any correlation between one user and the other user. Now let's take a look on this example. I have the rating like this one. And as you know, we have the item. Okay. So item, in this case, we have item 1 from Alice, the rating is 1. Item 2 from Alice, the rating is 3. Item 3 in Alice, the rating is 3, and so on. Now I want to know, based on the existing data, okay, based on this existing data, I want to know the probability of each of the rating. The probability of item 5 equals to 1. The probability of item 5 when the rating is 1 is 2 divided by 4. Because 2 of 4 ratings for item 5 had the value 1. Okay, so 2 among 4, the value is 1. What about the item 5 equals to 2? Nothing. Then the probability is 0. What is the probability that item 5 equals to 3? 1 among 4. What is the probability that item 5 equals to 4? 1 among 4. Okay, so the total will be 1. Now, we need to calculate the class conditional probabilities. So the class conditional probabilities means I want to know the xi given y. So this xi given y, let's say, I want to know the probability of x given item 5 equals to 1. Then what I can do is, when item 5 equals to 1, I want to know the probability that the item 1 equals to 1. Okay, so this one is the probability of item 1 equals to 1 when the item 5 equals to 1. When item 5 equals to 1. So how many of them? How many of item 1 equals to 1 given by the item 5 equals to 1? This is 1. So there are 2. Okay, there are 2 of item 5 equals to 1, and there are 2 of item 1 that the rating is 1. And 2 from 2, yeah, this the probability is 100%. Next, yeah, this is just I already determined the value. What is the probability that item 2 has the rating 3? Item 2 has the rating 3, given that the item 5 equals to 1. So given the item 5 equals to 1, given that the item 5 equals to 1, item 2 equals to 3, it has 1. 1 divided by 2. And then if you look at this one actually equals to the Alice rating 1. This 3 actually based on the rating of Alice 3. And this 3 is based on the Alice rating 3. So we want to check when the item 3 equals to 3, okay, when the item 3 equals to 3, because Alice gives 3, what is the probability? So it is 1, and this is 1 among 2. So 1 out of 2. And the last one, when the item 4 equals to 2. When the item 4 equals to 2, so I want to know. This is 5, this is 2. Then 1 out of 2 are 1 out of 2 is 2 for the item 4. Okay. Then by looking at the probability, when the item 5 equals to 1, given the x is the value of the Alice rating, then the probability is 0.125. So the probability that Alice will give this rating 1 is 0.125. So you need to do this one with different rating. So you need to do this one with the x given item 5 equals to 2. So if I want to predict the rating is 2, what is the probability? So you will do the same. When the item 5 equals to 2, I want to know what is the probability that item 1 equals to 1. Nothing. 0. So everything when the item 5 equals to 2 is 0. Then it will be 0. Okay. And then we will check when the item 5 equals to 3, when the item 5 equals to 4. So if item 5 equals to 3, okay, we have this one. Now you will check what is the probability when the item 1 equals to 1. No, 0. What is the probability when the item 2 equals to 3? No. What is the probability when the item 3 equals to 3? No. What is the probability when the item 4 equals to 2? No. then the probability will be 0 given the item 5 equals to 3. Next, what is the probability of x given item 5 equals to 4? When item 5 equals to 4, when item 5 equals to 4, it means this one. What is the probability that the item 1 equals to 1? 0. What is the probability the item 2 equals to 3? This is also 0. This is also 0. Okay, this is 1 out of 1 or 100%. However, the other is 0. 0, 0, 0, 0 multiplied by 1, of course, it will be 0. So the highest probability is this one, 0.125, because the other will be 0. Then the highest probability for Alice on item 5 is 1. Okay, so that's how to calculate the probabilities. So in many cases, there will be a lot of zeros. So as you can see, like this one, a lot of zeros. And when I calculate this one, there are also zeros. When I calculate this one, there are also zeros. So there will be a lot of zeros. Meanwhile, maybe it is not actually 0. It can be 0.0000 something. So we need to use smoothing. So there are many ways to do smoothing. I will not teach you the smoothing. If you need to survey, or if you have interest on doing this smoothing research, you can refer to any papers, or we can simplify this one to like or dislike. If there are so many numbers like this one, and the probabilities will be a lot of zero. If you just select only 0 and 1 or binary, then there is a high probability to have a value. So this is just an example. Oh, this is already, this is already, I discussed it with you. The probability of x given item 5 equals to 3. Okay, the probability of x given the item 5 equals to 3. And the probability of x given the item 5 equals to 4. Okay. So you can take a look on this one, and you can take a look on this one. So the practical probabilistic approach, as you may know, that there will be a lot of zero. Okay. So there are some researchers, they try to use clustering. So the clustering means we want to make groups. So assume users fall into a small number of subgroups. So we can create the clusters, and we can make prediction based on estimates. So we can just estimate the probability of Alice falling into the cluster C. So if the previous one, we want to calculate the probability, and the probability means what is the probability that Alice will give item 5 rating 1. Okay. But in this case, I will not predict the rating, but I just predict what is the probability that Alice will be in the cluster C. So the probability of Alice like the item I given a certain cluster and her previous rating, we can calculate with this formula. So I have the information about the clusters. And then I have the information about the rating. Then it will be the probability of that clusters. And then we will multiply that the probability of a given rating based on the particular clusters. So it is based on the model-based clustering or the mixture model. I will not discuss in details. So if you want to learn more, we need to understand how we can define the classes. Okay, so how many classes that we have and how many parameters that we need to learn. So some of the algorithm, for example, the EM algorithm is good to do this clustering. And other kind of probabilistic approach, we can use the Bayesian networks. So what we already did on the previous example is Bayes theorem. We can use the Bayesian network, or we can use the probabilistic latent semantic analysis. The empirical analysis shows that the probabilistic methods lead to relatively good results. So for the movie domain, so everything is it is related with the rating in the movie, yeah, it is good with the probability approach. And as you know, with the probability, there is no consistent winner. So it means when we try to predict item 5 equals to 1 and item 4 equals to 2, let's say the probability is 0.125. There is a high probability that in this rating, the probability is 1.11 something. But when something changes, okay, then it might be changed that the rating 1 becomes 0.111 and the rating 2 becomes 0.125. So no consistent winner because there will be some changes when you update ratings. And there are small memory footprint of the network models. So we cannot see the long dependency of the model. We just see from the short or the temporary data. There is another easy way to do the prediction. They call it slope one predictors. The idea of slope one predictors is simple and it is based on a popularity differential between items for users. So the popularity differential means just to see the difference. For example, I want to predict what is the rating, what is the possible rating on Alice at the item 5, given that Alice in the item 1 is 2, user 1 in the item 1 is 1, and user 1 in the item 5 is 2. So we can just use very simple slope 1 predictors. The possible rating for Alice at the item 5 is 2. 2 means the previous rating on the item 1 from Alice. And then given that the rating on the item 5 from user 1 minus by the rating on the user 1 on item 1. Okay, so one more time. Yeah. So we want to know what is the possible of rating of Alice in the item 5. So I want to check from the previous rating of Alice. This is 2. Given that there is a difference between item 5 and item 1 as much as 2 minus 1. So probably Alice will give rating 3. Yeah. So this is very simple way to predict the rating. Of course, there will be a lot of issues with this kind of simple ratings. For example, yeah, there will be a high dependency between item 5, or there will be a high correlation between item 1 and item 5, and so on. So the basic scheme is to take the average of these differences of the co-ratings to make the prediction. So the co-rating means, yeah, because I know the item 5, then I can use this item. So if I know the item 1, then I can use the information of item 1 to predict item 5. And we can just find the differences. Because this is only 1, so we just have a very simple subtraction. But if there are multiple, then we need to take the average. So for example, in general, we want to find a function of the form fx equal to x plus b. So x is any value, plus b is the bias. Bias means the difference. So that's why the name is slope 1, because we want to identify only based on the bias given on the existing data. Now let's see how if we deal with more data. Now I have Alice with rating 2 on item 1 and 5 on the item 2. And we have user 1 and user 2. They are co-rated items. But here, item 2 only has the co-rated item with user 1. For the item 3, we have the co-rated item for both users. So how can we predict the Alice rating on item 3? So with the slope 1 predictors, first we need to check the co-rating. The co-rating, there are 2 co-rating. So this is the item 1 and item 3. So one time it is rated 2 points higher. 5 minus 3. So it is 2 points higher. The other time it is rated 1 point lower. So this is 3, but this is 4. So it is minus 1. Then we have the average distance is 2. This is this one plus minus 1 divided by 2. So the distance will be 0.1. Okay, so this is the very easy distance based on the slope 1 predictors. And we can do the prediction for item 3 based on item 1 and Alice rating. How can we do that one? Based on this item 1 on Alice rating, it is 2. Okay. So 2 will be added with the distance. The distance is 0.5. Then I can do the prediction that Alice will give 2.5 on item 3. This is based on the item 1 only. Now, I want to consider the other item. I want to consider also item 2. Then how can I consider the item 2? There is only one co-rating. So this is only one co-ratings on item 2. Then I will check the distance. The distance is 3. Then based on the item 2, the prediction will be 5 plus the distance. This is 3. So the prediction will be 8. The rating will be 8. Somehow it is not feasible because if the rating maximum is 5, then how can we get this 8? So we need to calculate this on the average. So the overall prediction would be the possible or the predicted rating of Alice on the item 3 will be 2 multiplied by 2.5. This is based on this one. And then 1 multiplied by 8. This one divided by 2 plus 1. So what is 2? 2 means we have 2 co-rating. And 1, we have 1 co-rating. Then overall, we will divide with 3 things. So we will divide with 3 items that we use for the slope 1 predictors. And the possible rating or the predicted rating is 4.33 something. Then, yeah, most probably the rating is 4.33. Okay, so this is the slope 1 predictors. The other kind of prediction we can use predictor. The RF means rating frequency. So the idea is to take the rating frequencies into account for computing a prediction. The basic scheme is this one, the R hat. Okay, R hat, usually we call it, this is the rating, the predicted rating. Okay, the R hat is the predicted rating. The predicted rating will be the argument max. So we want to get what is the rating that gives you the maximum. What is the maximum? Here we want to calculate the frequency. And this is also frequency. What will be this one? So R, okay, let's look one by one. R means the set of all rating values. So R is 1, 2, 3, 4, 5, which is 5-point rating scale. And then F user, U, V, and F item, I, V, it describes how often a rating V was assigned by user U and to item I. Okay, so maybe it is a little bit complicated. Just simply like this one. I want to know the frequency. The frequency when the user U give rating V. For example, user 1 give rating 1. So I want to know the frequency user 1 give rating 2. I want to know the frequency user 1 giving rating 3. I don't want to know what is the user 1 giving rating 4. Okay. Now let's look at this one. I want to predict Alice rating in the item 3. In the item 3, so I want to know how many times Alice give the rating 1. Okay, so I want to know based on the users. How many of rating 1 from user Alice, how many rating 2 from user Alice, how many rating 3 from user Alice, how many rating 4 from user Alice. So in this case, the user Alice giving the rating 1, there are 2 times. The user 1 giving, sorry, let's say Alice first. Alice giving the rating 2, how many times? 0. Alice giving the rating 3, 0. Alice giving the rating 4, 1. And Alice giving rating 5, 1. Okay. So we can get this frequency. And because we are looking at the item 3 on the Alice, so we can just look at the item 3. So this is the F item for a particular item that get the rating V. So again, we will check. The item 3 given the rating is 1. How many times? The item 3 that get rating 1. There are 2. And then the item 3, how many times that has the rating 2? There are 2 frequency. The item 3 given that rating 3, we have 0. The item 3 given the rating 4, there are 0. The item 3 given the rating 5, there is 1. Okay. Now, based on this formula, we want to get the maximum. What is the maximum? It is the maximum according to the particular rating. So if the rating is 1, what is the rating is 1? When the rating is 1 from the user A and item 3, for the user the user A on the item 3, when the rating is 1, when the rating is 1, the result is 2 multiplied by 2, then it is 4. The user Alice on the item 3, when the rating is 2, when the rating is 2, this is 0 multiplied by 2, then 0. The user Alice and the item 3 given the rating 3. This is 0, 0, then 0. Anything multiplied by 0 is 0. User Alice on the item 3 given the rating 4. 1 multiplied by 0, then 0. And then the user Alice on the item 3 given the rating 5. That is 1 multiplied by 1. And it's only 1. Now, among all the multiplication, what is the maximum? The maximum is 4. Okay. Because the maximum is 4, now let's take a look. What is the rating? The rating is 1. Then we can say that based on this RF rank predictors based on the reading frequency, the possible rating for Alice on the item 3 is 1, because this is the high value based on the frequency. Okay. So here, because there are 2 of Alice and then there are 2 of item 3, then we can have the prediction that Alice will be 1 for the item 3. So there are, we learn a lot of algorithm filtering. So when we try to summarize the recent methods, so the recommendation actually it is concerned with learning from noisy observation. The noisy observation means any random ratings can be given. So we want to predict the y. We want to put the, and once we know the rating, we need to check whether the predicted rating and the actual rating, whether it is minimal or not. So if we have a model, you know already about the machine learning, we do the performance verification. In the performance verification, we usually check the predicted rating with the actual rating. And if it is minimum, then it is good. If it is not nearby 0, then the model still need to be improved. So there are a huge variety of different learning strategy that have been applied trying to estimate the fx. Okay, so there are so many algorithms how we can apply the prediction. So if we use the non-parametric neighborhood models, then we can just apply with some. There are many statistical methods for non-parametric neighborhood, or what we already learned today. We can use the MF model, which is the matrix factorization, or maybe in some weeks later, we will learn about the other kind of machine learning, for example, the decision tree. Okay. So you can use the SVM, you can use neural network, you can use the Bayesian network, and so on. The first type of the factorization, so we learned about the factorization before. It was applied to the Netflix. So in 2008, some researchers, they used the factorization to recommend the Netflix movie. And the price of $1 million US. Okay, so because at the time it's very famous, it's very popular competition. So people try to make a prediction, and the factorization can improve like 10% on the RMSE. Okay. Do you know RMSE? If you join the data mining, I guess you know the RMSE, which is the root mean square error. Okay. Based on the root mean square error, there's an improvement of 10%. And the database or the data set is very large, like 100 million ratings with 480,000 users and with 18,000 movies. And the last ratings or users will have, or we have the set of K. So you can see this is the result from the paper. The root mean square error optimized to 0.8567. So we will learn later about some metrics. We can see the MAE, we can see the RMSE. Okay? So those kind of things are the metrics for the recommendation system. So there are some issues in the collaborative filterings. It is easy to understand, well understood, and it works well in some domains, and no knowledge engineering required. So as you can see, with the matrix factorization, we can just use the linear algebra, and then we can have the u, v, and singular values. With the association rules, we can just apply the support and confidence. With the probabilistic, we can just measure the probability. But the cons means the disadvantage, it requires user community. It means we need to get data from users. We need to get data from people. We need to get data from customers. And sparsity problem. Sparsity problem means when the value 0 exists, or when many users did not give rating. That's a problem. We cannot use collaborative filtering in that case. And there is no integration of other knowledge sources. So for example, if I want to recommend a laptop, okay, so it is not easy to recommend a computer because the computer or laptop, there will be some more knowledge. For example, what is the size of the hard drive? And what is the size of the memory? What is the monitor size? Maybe what is the spec of the computer, whether it is CPU or GPU, and etc. So it requires some knowledge. But with the code, we just use on the reading. And no explanation of results. So sometimes when we get the value, okay, like what you saw before, okay, we can explain this one. Based on the higher frequency, then we can get the predicted result is 1. Or using this one, maybe it is also available for our interpretation. Okay, the result is 4.33 for the prediction. But when you use the matrix factorization, yeah, it is difficult because we do not know what is the information on the matrix. Okay, there is no explanation of results if we use some higher level approaches. So the question is, what is the best collaborative filtering? So there is no best method. Okay? There is no one fit for all methods. So in which situation, in which domain? And sometimes there will be some inconsistent findings. If you have the same domain and the same data set, yeah, of course the result will be almost similar. And differences between methods are often very small because we use only rating. If the rating is from 1 until 5, of course the result will be very small. One method, the method 1, maybe they will give you 4.33. Method 2 maybe will give you 4.23. So there is a small difference. And how to evaluate the prediction quality? So we will learn about the MAE, RMSE. So what does MAE 0.7 actually mean? Is it good or is it bad? If we have the rating between 1 until 5, maybe, okay, this is already good. But if the rating is between 1 until 100, then it might be bad. And serendipity. It is difficult to understand the serendipity. We learned this one from the first lecture. It is the novelty or surprising event. And it is not yet fully understood. And what about the multi-dimensional ratings? The multi-dimensional rating means like what you see on the movie. So I have the movie rating, but I also give the rating based on the actor. I also give the rating based on the music of that movie. I also give the rating based on the director of that movie. Then it is the multi-dimensional rating. Collaborative filtering still have some issue on that one. And yeah, you can try to figure out. Maybe there's a good research topic for this one. Let me stop first. I will continue after the break.